Project timed, technology-based instructional materials for the enrichment and development of mathematics instruction. A requirement for the completion of Instructional Leadership Program for District and Division Supervisors course. Dulce M. Kamaya, Public Schools District Supervisor of Depth Ed City Schools Division of Malolos, District 10. The current situation with regards to result of the second periodical test of the 4 elementary schools in the district, data showed that mathematics has the lowest MPS among the different learning areas with 81.95%. Looking back with the teaching skills of the 11 teachers in the district as they were observed using the COTRPMS, 4 of them consistently incorporate technology in teaching while 2 of them occasionally used technology in their teaching and 5 of them need assistance in using technology in teaching. Technology has the potential to transform learning environment in ways that will benefit the 21st century learners. As with many emerging societal trends, younger generations are the first to incorporate technical change into their everyday lives. Increasingly, however, our nation's schools also are becoming adopters, dramatically changing the ways learners and teachers use technology in the classroom. The learners of today grow up in a digital world. Instead of viewing technology as a distraction, educators must take advantage of it to increase their engagement. To ensure that learners are getting the most out of every lesson, contents must be presented in a way that is appealing to them and relevant to their experiences and interests. Based on Depth Ed Order No. 2 Series of 2015, Guidelines on the Establishment and Implementation of RPMS, teachers must possess the 3 core skills: proficiency in both oral and written communication and computer ICT skills. They must learn to adapt to societal trends and incorporate use of technology in the delivery of instruction. Thus, with the aim of transforming the learning environment, the application project, Timed Math Instruction is conceived to develop technology-based instructional materials to help enrich math instruction and apparently improve the academic performance of the 27% or 36 low-performing Grade 1 learners of Kaniagan Elementary School whose academic grades ranged from 75 to 78 and did not master the 4 least learned skills in mathematics during the second rating period. The project objectives focus on the following. At the end of February 2019, it will develop 4 contextualized technology-based instructional materials and lessons on the 4 least learned competencies, and it will enrich or enhance the mastery of the 4 least learned competencies of Grade 1 learners in mathematics by 10%. Competencies that need to develop under Key Result Area 1 are instructional supervision and technology leadership. It is expected at the end of its implementation, we can produce or develop contextualized math lessons on the 4 least learned competencies and contextualized technology-based instructional materials saved in the flash drives and CDs as outputs. Likewise, expected outcomes are 1. Developed contextualized technology-based instructional materials on the 4 least learned competencies, and 2. Increased of at least 10% on the academic performance in mathematics of the 36 low-performing Grade 1 learners of Kaniagan Elementary School. Length of the study ran from September 24, 2018 to February 22, 2019. Beneficiaries of this project are the 27% or 36 low-performing Grade 1 learners of Kaniagan Elementary School and the 11 teachers of District 10. Results of this application project would be of great help also to the school heads to encourage teachers to use more often technology to make teaching and learning more interesting, engaging, and effective. Similarly, this project wants to address the question: how will the school heads and teachers benefit from this application project? Obviously, the school heads may use this as one of the interventions to improve the academic performance of the learners and lead them to mastery of the least learned competencies in mathematics, and assist the teachers in preparing/using contextualized technology-based instructional materials and lessons. The teachers may benefit also by utilizing the said technology-based materials in the delivery of instruction to make it teaching and learning more interesting, engaging, and effective. The researcher constantly supervised them through the action steps of 3 milestones, doing the following activities to realize the said application project with the use of Facebook group chat using Messenger application TIMED10 and actual observation and implementation of the project in the said school. Milestone 1, Action 1 is the pre-implementation. After 3 weeks of ILPDDS training at Hotel Pampanga at Hacienda Gracia in Pampanga, the first step is to present the concept paper and project template to Dr. Melissa S. Sanchez, OIC Assistant Schools Division Superintendent and concurrent CID Chief, for consultation and approval of the title last September 24, 2018. The template was recommended for approval of the Schools Division Superintendent. Likewise, on the same date, a consultative meeting with the school heads was conducted wherein the project template on the ILPDDS application project timed math instruction was presented and seeking for their support and cooperation to make the project realized. School heads shared their own insights about the project and pledged support and cooperation in the implementation of it. Another meeting was set last September 28, 2018 with school heads, Grade 1 teacher leaders and school ICT coordinators to discuss and finalize the activities or milestones to realize the project. Everybody offers their full support and cooperation to make it work. Letters asking permission to conduct the project was sent and approved by the Dr. Merlina P. Cruz, CESO6, Officer in Charge Schools Division Superintendent, and the 4 school heads of District 10. Implementation schedule as stated on the slide started with the following: October 22 to 24, 2018 Slack on contextualization, localization and indigenization and 21st century classroom instruction, December 4, 2018 the submission of instructional materials, December 7, 2018 the conduct of pre-test, December 10 to 14, 2018 to January 18, 2019 validation of instructional materials, January 22, 2019 post-test, and from January 22, 2019 to February 22, 2019 data gathering, interpretation of results, conclusions, and recommendations. Milestone 2, Implementation. As initial activity to implement the project is to conduct a district action cell on contextualization, localization and indigenization and 21st century classroom instruction last October 22, 2018 at Kaniagan Elementary School. The training was spearheaded by the researcher along with the school heads, master teachers and ICT coordinators. Workshop on the preparation of instructional materials, both traditional and technology-based, was made on October 23 to 24, 2018, wherein the 11 Grade 1 teachers in the district were given the tasks to work on lesson plans, instructional materials, and pre/post tests on the 4 learning competencies. These are the 4 competencies which did not master by the 27% or 36 Grade 1 learners. The competencies made more specific using the curriculum guide code. Moreover, the researcher monitors the project through the use of FB Messenger or group chat and timed 10, wherein communications and submission of outputs were done during breaks or lunch time. Milestone 2, Implementation. Action 1, revealed the 27% or 36 Grade 1 respondents classified according to their general grades from 75 to 78 during the second rating period, and these are also the learners who did not master the 4 least learned competencies in mathematics during the second rating period. Pre-test was conducted on December 7, 2018, wherein the respondents were divided into 2 groups, the control or traditional group and experimental group or technology-based group. This pre-test was conducted before the teachers made their remedial teaching or interventions. Results of the test revealed on the table. Validation of instructional materials, both traditional and technology-based, made by the 11 teachers in the district was done from December 10, 2018 to January 18, 2019. Each school was assigned to work on one competency, making both traditional and technology-based instructional materials along with the school ICT coordinators. Materials were validated by Dr. Teresa R. Manlopez, EPS1 Mathematics, Mrs. Rosita S. Lalick, LRMDS Representative, and Mrs. Maria Teresa C. Manalo, District Mathematics Advisor and Principal 2 of Caniagan Elementary School. These materials were also validated during the classroom observations and video viewing. Validation results showed that it passed the 7 criteria under content with 27 scores out of 28, 19 points out of 20 for presentation and organization, and 24 out of 24 for accuracy and up-to-datedness of information. To summarize the results, content had a rating of 3.857 or very satisfactory. Presentation and organization got 3.800 or very satisfactory, and accuracy and up-to-datedness of information got 4.000 or very satisfactory. All indicators passed the LRMDS criteria. Milestone 3. Action 1. Post-implementation showed the scores of the 36 low-performing Grade 1 learners after remedial teaching was done in both 2 sets of subjects. Post-test results revealed increase in scores of both subjects after they underwent remedial teaching. After exposing the 2 sets of subjects to 2 different stimuli, one where the subjects were taught through traditional instruction wherein lessons were presented using charts, flashcards, and manila papers, and the other subject taught through technology-based approach where the lesson were presented in a PowerPoint presentation and hyperlink or use of Internet. The result of the post-test improved. Table 1 shows pre-test results of learners without interventions made. Shows the scores of the learners during the pre-test separated into 2 groups: learners who underwent technology-based instruction and learners who received instruction using traditional approach of teaching. As reflected on the table, the learners under the 2 groups have a mean difference of 0.7778 based on their individual means of 6.2222 and 7.000, respectively. Examining their means and standards deviations, the performance of the learners who underwent technology-based instruction and traditional approach have almost no statistical difference. However, Table 2 post-test results of learners using traditional and technology-based instruction reveals the performance of learners using technology-based instruction and traditional approach of teaching. As observed on the table, the learners who received instruction using technology have a mean score of 24.8333 with a standard deviation of 1.68907. On the other hand, learners who were taught using traditional approach of teaching have a mean score of 17.5 with a standard deviation of 3.95935. Based on the mean difference of 7.333, it can be deduced that learners under technology-based instruction perform better than learners under traditional approach group. Table 3. Paired samples statistics, t-test. Between pre-test and post-test using technology-based instruction, paired samples t-test is used to compare the pre-test and post-test results of learners were taught using technology-based instruction. As observed on the table, there is a significant difference in the pre-test results. M equals 6.2222, SD equals 3.24591, and post-test results, M equals 24.8333, 1.68907, conditions, T, 17, P equals 0.000. The results suggest that technology-based instruction can be utilized by teachers to deliver instruction to enhance their academic performance. To compare the improvement of performance of learners using the 2 instructional delivery strategies, Table 4 shows paired samples statistics, t-test, between pre-test and post-test using traditional approach. Results revealed that there is a significant difference between the performance of learners using traditional approach during the pre-test, M equals 7.0, SD equals 4.0, and post-test, M equals 17.5, SD equals 3.95935, conditions, T, 17, equals negative 19.098, P equals 0.000. Although, the results on both instructional delivery strategies are both significant, it can be deduced from the computed values that use of technology results to better performance of the learners in the post-test. To further determine if there is a significant difference in using the two instructional delivery strategies, an independent samples t-test is conducted to compare the performance of learners during the post-test after each group of learners were taught using technology-based instruction and traditional approach. Group statistics shows the result. There is a significant difference in the post-test performance of learners who were taught using technology-based instruction, M equals 24.8333, SD equals 1.68907, and traditional approach, M equals 17.5, SD equals 3.95935, conditions, T, 34, equals 7.228, P equals 0.000. The results suggest that technology-based instruction really does have an effect on the learning acquisition of the pupils based on the post-test results of the two groups. Specifically, the results suggest the use of technology in the delivery of instruction among learners instead of using traditional approach of teaching. Based on the findings and conclusions, the researcher recommended the following. 1. Validate the results of the study by conducting a similar study with larger number of subjects to ensure its replicability. 2. Explore technology-driven instructional materials and strategies to keep abreast with the learning styles and needs of our present learners. 3. Teachers should immerse themselves in ICT trainings to capacitate them in the development of high-technology instructional materials. 4. School heads should train and encourage all teachers to frequently use technology-based approach in classroom instruction. Thank you and God bless us all.